Okay, so now we're going to talk about infrared spectroscopy, which remember we typically call IR, right? So infrared spectroscopy, do you remember what it measures? It measures kinds of bonds, okay? So, and we're going to map that to functionality, right? We're going to map that to functional groups, right? Because that is a carbonyl, right? And that is an alcohol, and they have different bonds. So measuring kinds of bonds is tantamount to measuring functional groups, all right? So because bonds act like springs, didn't have an extra slide in there, because they act like springs, it's important to appreciate that, for example, a carbonyl here, right? This carbonyl bond stretch doesn't have the same frequency, which we're going to match to energy, as a hydroxyl stretch, right? So this stretch, this bond right here, acts differently. If you consider them to be springs, they act differently because they're different bonds, right? So can you see that if I get, say, a signal of, let's say, 14 when I measure a double bond, and I get a 4 when I measure this over here, and suppose I get a readout and it says 4, instead of 14, it doesn't say 14, it says 4. I'm going to go, oh, I have an alcohol, right? Because it says 4 instead of 14. Now let's look at what some of those readouts might look like. Actually, let me say one more thing. Of course, okay? Of course they have different frequencies, right? Because they're different bonds. So let's look at what one of them looks like. All right, so it turns out that this bond has a very deep absorption at this particular frequency of an IR spectrum, right? So it's wave numbers. We don't really need to know what wave numbers is right now, but at about 3,400 wave numbers, you get a deep peak when you have an OH bond in there, as in a hydroxyl, right? Do you see that? That OH bond? A big deep peak. Now watch this. Let's look at a bunch of them. Here is, can you see that? Is that too small? Here's methanol. And can you see we've got that same bond right there? And look at, wow, there it is. That's the 3,400, right? Here's ethanol, right? And there it is. Here is propanol. And there it is. Here is, oh, who knows what that is? 1, 2, 3, 4, 5, 6, 7. So it's 3-heptanol. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's 5-methyl, 3-heptanol, right? There's that bond, and there's the peak. Here is, wow, tert-butanol. There it is, and there's the peak. Here is isopropanol. This is rubbing alcohol. Look at that. There it is, and there's the peak. Here's phenol. Look how different these molecules are, and yet it's there every time. And here's cyclohexanol. There's the OH, and here's the peak. And here's, whoa, look at that. Do you know what this is? This is cholesterol, but it's got that OH on there, and there's the peak. Okay, so can you see how something that telltale, that reliable, is going to be super useful to us when we're trying to analyze compounds with a technique as simple as infrared spectroscopy? All right, so let me give you one more example, and then we'll move on to the next topic. All right, the one last example is, right, I showed you this before. This was figure 3. In ethanol, we get that big peak right there, and watch, it's not there. So there's 3,400, right? Where is it? It's not there because we don't have it in this compound. And we have something there, right? But it's not that OH. You see that? It's not big and deep. But this bond has a long, narrow peak at about 1,700. This is about 1,700, okay? And so in another venue, I'll show you a bunch of spectra with this carbonyl carbon in it, and you'll see that that's also very reliable. Okay, so the one thing I'd like you to take from this video, infrared spectroscopy, IR tells you functional groups, right? And be more specific now. In this case, OH, you get a telltale signal at 3,400, or that you get a telltale signal at 1,700, okay? Now, there's a bunch of other things here that we don't care about, so that's a little unsettling to students, right? This is called the fingerprint region. In spectroscopy, especially with IR, we're not going to be interested in assigning meaning to every peak. We're going to be looking for telltale signs, and here are two of them. Memorize those two peaks. When we have a big, deep, wide peak at 3400, we have in a hydroxyl group. When we have a narrow peak, a narrow, long peak at 1700, boom, we have a carbonyl carbon. All right? Hope that's helpful. Let's go practice some more.